Have you ever felt like the world of AI has its own secret language? You are definitely not alone. But here's the thing, you don't need to be an engineer to get in on the conversation. We're going to give you the vocabulary, the key concepts so you can follow along, ask the smart questions, and really get a handle on the forces that are shaping our world. You ready to dive in?
It's a total alphabet soup out there, isn't it? AGI, XAI, GANs. It is so easy to get lost. But here's the secret. Behind every one of these acronyms is a really powerful idea. A key that unlocks how AI works, where it's all headed, and maybe most importantly, how we can shape its future. So today, we're going to decode it all, one concept at a time.
All right, let's start with the big, foundational ideas. You can think of these as the architectural blueprint for an artificial mind. These are the big picture goals, the fundamental structures that, really, everything else is built on top of.
Okay, first up, the big one, AGI. This is kind of the holy grail for a lot of AI researchers. We're not talking about an AI that's just a grandmaster at chess. No, we're talking about a system that has the same flexible, adaptive, reasoning intelligence that you and I have. Now, we're not there yet, not even close, but AGI is the North Star that's guiding this entire field.
So if AGI is the ultimate destination, then an AI agent, well, that's the one actually driving the car. It's the doer. Think about a character in a video game that reacts to your moves, or a robot in a warehouse that's navigating the aisles, or even just the software in your smart home that's adjusting the thermostat. It perceives, it decides, and it acts, all on its own to get its job done.
So how does an AI actually know anything? Well, that's where knowledge representation comes in. You can think of it as the AI's internal library or its mental map of the world. It's how facts, rules like, say, all birds have wings, and the relationships between things, like how a beak is a part of a bird, are all organized. Without that internal library, an AI can't make any logical connections or reason about the world at all.
Okay, so we've got the blueprint. Now let's head down to the engine room. How do these systems actually learn from data, generate brand new things, and handle these really complex tasks? This is where things get super interesting. So let's talk about GANs, or Generative Adversarial Networks. Just imagine this. You've got an art forger, that's the generator, and it's creating these perfect fake paintings. And then you have a brilliant art detective, the discriminator, who's trying to spot them. Every time the detective catches a fake, the forger learns and gets better. And every time the forger makes a better fake, the detective has to get smarter. Through this constant back-and-forth competition, the generator gets so good that its creations are basically indistinguishable from the real thing. This is the magic behind all those hyper-realistic AI images you see everywhere.
You know, training an AI model from scratch takes a ton of data and a ton of time. Transfer learning is this brilliant shortcut. So instead of teaching an AI to recognize cats from zero, you can just take a model that already knows what animals are and then just fine-tune it. It's kind of like using your knowledge of Spanish to learn Italian way faster. You're not starting from square one, and that saves a massive amount of time and resources.
We all want smarter AI, right? But we also really value our privacy. Well, federated learning offers this really clever solution. Instead of sending all your personal data to some central server, the AI model itself comes down to your device, like your phone's keyboard. It learns from your typing to improve its predictions right there, locally. And then it only sends back the general improvements, the learning, not your actual messages. It's a really powerful way to make AI better for everyone while keeping your information secure. You know, we humans experience the world through multiple senses at once. Well, multimodal AI gives machines a very similar ability. Think about a self-driving car. It sees a pedestrian with its camera, it hears a siren with its microphone, and it reads a road sign. It's combining all these different types of data, these different modes, to get one complete picture of what's happening around it.
This is really the next level of automation. It's not just about doing the same repetitive task over and over again. Intelligent automation is about tackling complex workflows that actually require decision-making. So, for example, when it's processing an insurance claim, it can read the documents, it can verify the data, and it can even make an initial judgment on whether the claim is valid. It's about automating not just the doing, but the thinking as well.
Building powerful AI is one thing, but making sure it's reliable, understandable, and, safe, that's a whole other challenge. This next part is all about the human element. It's about the concepts that help us build trust and make sure these powerful systems are working for us, not against us. And here we are at one of the biggest challenges in modern AI, hallucination. This is when a large language model, for instance, just confidently makes something up. It generates text that sounds perfectly plausible, totally factual,
but it's completely false. And it's not lying in the human sense, it's just putting words together in a statistically likely way that just happens to be wrong. And this really gets to the core of the dilemma, right? If these incredibly powerful systems can just invent facts out of thin air and do it with total confidence, how can we possibly trust them with critical tasks? I'm talking about things in medicine, or law, or finance. It's a question we absolutely have to answer.
So, how do we solve this? Well, explainable AI, or XAI, is a huge part of the answer. For way too long, a lot of AI models have been what we call black boxes. Data goes in, an answer comes out, but what happens inside is a complete mystery. XAI is the antidote to that. It's all about designing systems where we can actually ask, hey, why did you make that decision? And get a clear, understandable reason back.
XAI is a great step for sure, but sometimes you just need a person involved. That's where a human in the loop comes in. This is a system where the AI does all the heavy lifting, say flagging thousands of suspicious transactions, but a human expert makes the final call. It's the perfect partnership, really, combining the incredible speed of a machine with a common sense and ethical judgment of a person.
This is where AI safety gets terrifyingly real. An adversarial attack is when someone intentionally tries to fool an AI. So imagine putting a little sticker on a stop sign. It just looks like random noise to you. But to a self-driving car's vision system, it makes that sign look like a speed limit 100 sign. The consequences, obviously, could be catastrophic. This is exactly why building robust and secure AI isn't just a technical challenge, it's a moral imperative. All right, for our last section, let's zoom out. What are the big picture concepts that are going to shape the future of AI and its role in our society? Think of these as the guiding principles, the rules for the road ahead.
This slide lays out a really crucial checklist. First up is AI alignment. This is all about making sure an AI's goals are our goals, so it doesn't misunderstand an instruction and cause some huge unintended problem. Next, digital ethics and governance. These are the actual rules and policies we have to create to make sure AI is used fairly, things like laws to prevent bias in AI hiring tools. And finally, computational resources. This is the reality check. All of this, it requires immense computing power, which has very real environmental and economic costs we have to think about.
We usually think of AI as living way up in the cloud, right? But Edge AI brings it right down to your fingertips. It just means running the AI models directly on your device. Think about Face ID on your phone, or those real-time translation apps that work even when you're offline. All the calculations happen right there, which makes it faster, more private, and a lot less reliant on having a constant internet connection.
Ultimately, when you boil it all down, the real takeaway is this. The technical challenge of just creating AI is massive, yes. But the greater challenge, the one that really matters, is creating AI that is aligned with our values, transparent in its reasoning, and fundamentally beneficial and trustworthy for everyone. So there you have it. You now have the vocabulary: AGI, XAI, GANs, hallucination. You've got the tools to understand the headlines, to join the debate. And that knowledge, that's your power. So the real question is, how will we, as an informed society, use it to shape the future of this incredible technology?